All right. Hi, everyone. Thanks for joining us this morning, afternoon, evening, wherever you are. We have a pretty exciting show with us today. We'll likely get started in just a couple minutes here to make some folks able to trickle in. But before we do that, do you guys just want to say hi real quick? With me today is Paul Madsen.
Hey, Gehrig.
Favorite community member, I think. Also the best Twitter follower of the bunch, I might say. And we also have our developer, advocate, and evangelist, Cooper. Hey, Cooper.
Hey, everyone. Thanks for joining. Thanks, Gehrig, for hosting.
Yeah, of course. Happy to switch things up. I felt like this was a little bit of the Avengers. When you get down to just like the final three most important heroes in the show, and you're like, oh, now's the real time to pay attention and watch and learn.
That's funny because I felt like this was, a similar scenario where you guys can carry on and make sure we win the battle. So I appreciate that.
Don't go to the woodshed, Cooper. Don't go to the woodshed. It's
very good. So we have an interesting topic today. I think, last week, if I remember correctly, we talked about bad hackathon ideas. We're kind of doing the inverse today. So we got that out of our system. Now we're here to talk about winning hackathon ideas. So with us, we have a pretty good crew here to do so. Please feel free to post questions in the Zoom or YouTube, whatever's convenient to you. We might answer them as we go. We might answer them throughout. We'll see how we feel and how good the questions are, really. But with us today, we're going to get started here. And really, this is kind of a brainstorming exercise, real casual. Are you guys able to see my screen, Lena, or just the entire chat view? Might have to disconnect here.
I see the keynote kind of, this is what's the current slide and this is what the next slide is view. I don't know if that was intentional.
No, that's a little bit of a tease. We don't want that. Let me disconnect here.
And yeah, thanks everyone for joining via YouTube or joining us from Discord. Like Gehrig said, please feel free to let us know if you have any questions or, at the end, validate or invalidate an idea as, something that should be built on HCS. More than happy to dive into that there.
Yeah, and there, I just disconnected my audio, so I want to make sure you guys can hear me okay.
We still can.
All right, beautiful. Okay, well, cool. As I was mentioning before, really trying to find that winning hackathon project with you guys. This is an ongoing effort. I think in the next coming weeks, we'll be talking about more about pitching, how to refine and have the perfect pitch. But this is really for the, concept, making sure you're locked into the right idea, making sure you can kind of go through an idea maze to figure out what you want to spend your resources and time on, and hopefully how to win some prizes. This is, the backdrop really for what we want to talk about today. What are the different HCS specific challenges? There's some really good other challenges, I think, that are more foundational tools that are super critical and important. I think there's a couple signing ones, there's a Kafka integration, stuff that a lot of people will use. But for some of us that want to develop more robust applications or use cases, this is the one for you. And we'll dive all into this. I think before we do, I'm actually going to hand it off to Paul, who's going to talk a little bit about decentralized identity, which should give us a helpful backdrop, I think, for a lot of the different use cases we're going to talk about today. So let me stop sharing my screen here.
I'm going to argue that building a project around decentralized identity, specifically around some new functionality that we've made available, specifically a new SDK, would be a quote unquote winning project. So decentralized identity, the premise is that the identifiers and credentials comparable to the things we store in our wallet today, there's value in being able to anchor those via HCS into a business network. And by doing so, facilitate, subsequent lookup, retrieval of the metadata associated with those identifiers for the normal HCS reasons of trustless, robust, lookup, and auditable logs, etc. So here's a slight tweak to the normal architectural diagram for decentralized identifier that is common to all DLTs that are supporting this use case. So at the top is the fundamental interaction or interactions. There is an issuer, and that is some business or enterprise, or it could be a human, an individual, who issues identities or credentials to some subject or holder, typically about that subject. So in the archetypical use case, the DMV might issue a driver's license as a credential, a verifiable credential, the name being normalized in the W3C. And the subject, like we do for the cards in our wallet, they store those in a digital wallet on their phone. So just like a crypto wallet, you store some combination of keys and identity or information that allows you to transact with the information in that wallet. On the other side of that relationship is the subject is able to present those identities and those credentials to verifiers. So again, in the archetypical driver's license use case, that verifier could be a bar. I'm trying to get in and I need to prove I'm of age, or the verifier is a police officer and I'm trying to prove that I'm a legal driver. So that's kind of the fundamental identity flow. And I didn't mention Hedera and I didn't mention DLTs in any of that. The contribution of Hedera or DLTs in general to this model is the proposition that by storing metadata, storing artifacts about these credentials, about these identities in a DLT, then we can facilitate the subsequent lookup, the read operations, the queries where verifiers need to retrieve additional information. So not only does that DMV issue me a credential for me to store in my wallet, the DMV also records that to a DLT, effectively anchoring that credential, that identity into the DLT, and thereby enabling the downstream bar or restaurant or police officer to be able to look that up later and retrieve useful information. Could be public keys, it could be endpoints, or it could be hashes of credentials. So that's the basic proposition of this decentralized identifier model. Hedera has perhaps a slight twist on that default model, because with Hedera's implementation of identity, specifically how we use HCS messaging for those anchoring operations, these artifacts, these hashes, these DID documents don't get stored on the main net. They might get stored in the mirror net, but the assumption is they're going to get stored on some other business network or application network, right? Could be a set of computers that have come together to form this network that by definition, dump truck is dropping off dirt today. So this
sure that
community,
he has the credentials to do that.
Well, I'm not going to go over there to verify at the moment. I think the dirt is credibility enough. It's real. So some network of businesses come together, and by definition, they're interested in the identities issued by each other. And there's value in establishing this business network as a means of staying in sync effectively on this registry of identity artifacts. So that's the proposition. And we've recently made some concrete progress to making this real. On the left-hand side, you'll see the issuer side. the specifics of how you anchor these artifacts into a business network via mainnet, those are defined in what's called a DID method. DIDs in general are somewhat abstract, and they must be bound to a particular, in this case, DLT like Hedera. So our DID method specifies how you use HCS messages to manage the life cycle of these identities. And similarly, we have a document that defines how you use HCS to manage the life cycle of verifiable credentials. So our DID method is a document that was recently added to the W3C registry for these DID methods that says, if you have just issued a credential to a user, this is how you record that creation to the business network. This is what the HCS message looks like, by which you say, hey, I just did this. Similarly for updates and deletes for credentials and the DIDs. And on the other side, how do you verify that if presented with a credential or a DID? So that's the architecture. And again, to facilitate apps building on this model, we've released a Java SDK that implements this messaging pattern and allows a business either playing the role of an issuer or a verifier to easily tap into this messaging pattern through the SDK.
And so, Paul, just to kind of reiterate what we're understanding here, it sounds like you send this DID specification to an agreed upon HCS topic. This is agreed upon by the business network, which is effectively the people that are interested in that information. Is that correct?
Correct. Yeah. So to bootstrap a business network effectively is to define one or a number of topics that the business network participants are interested in. And so once that's established, the members of the business network can send messages to that topic, complying with this particular normalized syntax for what those messages look like. And then after mainnet's done its thing and after those messages have flown out to the mirror net, the business network who have subscribed to that topic at the mirrors retrieve those messages. And of course, they retrieve them timestamped and ordered and all the HCS goodness. And then they update their database, right? Their registry of these artifacts. And what HCS enables is this trusted, secure synchronization method between the members of the business network.
Got it. Thanks.
And I guess the proposition or the opportunity for a hackathon member is to build on this pretty basic plumbing and build out a use case that highlights both perhaps the unique advantages of this DID architecture, particularly the performance of HCS messages. Those create, update, and deletes all logically are write operations. They're changing the state of the registry. And if implemented naively, then you would be constrained in the throughput of how many operations you could support. But because we're doing this through HCS, we've got the throughput of Hashgraph itself, the throughput of HCS, or similarly high throughput of crypto payments. So a use case, an identity use case that leveraged that performance would be cool, right? Even more so than just demonstrating that the plumbing worked, one that demonstrated that potentially you could only support a particular use case on HCS's identity model would be very interesting. So Internet of Things comes to mind, right? Internet of Things implies a lot of identities depending on the nature of the device. And if every device at manufacture time was issued an identity in this model, then the creation of that device, some small sensor or comparable, would be recorded via this pattern into an IoT chain, some supply chain for device manufacturers, such that when that device was then shipped and sold and deployed somewhere, that identity issued to the device could be looked up. Just like my driver's license, the device's identity and various attributes, firmware version, last software upgrade, all the identity attributes that are meaningful to a device could be retrieved and looked up through this model. I'd love to see that.
That'd be pretty neat. And then just to be clear, it sounds like you can have multiple issuers that are approved. So if there's multiple device manufacturers, they could all be simultaneously using the same specification.
Indeed, and if the keys of those manufacturers were listed on the topic, then you could control who could write to this topic by controlling that key list. So you could prevent inappropriate DID registrations, for instance, by just tapping into that permissioning model based on keys.
Very cool.
And Paul, to clarify that, and anyone looking to do something like this in their hackathon, is this a problem that has to be tackled kind of as a whole, or do you see specific kind of sections in here, whether it's issuance, verification, maybe even just storage, that could be a viable project for the hackathon?
So that's a good point. Ultimately, I think a credible full scenario implies or demands both issuance of credentials and subsequent presentation of credentials, because otherwise you're just addressing half of it, really. Which isn't to say that I don't even know if this is within the rules, but one project could tackle issuance and persisting that to the ledger or to a business network, and some other project could demonstrate reading those.
Yeah, that totally makes sense. So you could have like a SaaS model where you're, providing that service to other applications that are looking into DIDs, where you do the issuance and verification, kind of like as a service.
Yeah, indeed. And others would hook into you on the back end.
Gehrig, I don't know if you're seeing these, but I'm dropping some of the questions that we have from YouTube into the Zoom chat. One of the most notable ones is Paul available for offline help and answering questions about implementing this DID specification?
Yes.
That's great. And I think they could get in touch with you on Discord is probably the best route, Paul.
Sure, or Paul at Hedera.
Oh, beautiful. And then I think you're going to jump into some of the more specific questions we have about address books and the like, but you're probably getting into that, I believe.
Sure, I can talk about how that works. Ultimately, the proposition is that the credential that gets presented to that verifier has within it a so-called DID, decentralized identifier. And part of our DID method specification was defining the syntax of what those DIDs look like, a somewhat trivial schema to allow the verifier to deconstruct the components of that identifier. Specifically, in this architecture, if I present a credential, the driver's license as an example, the verifier does a couple of things. First, it validates the signature on the credential and determines that, yes, indeed, it was previously issued by the DMV. It's also going to check my signature as a means of proving that it is indeed my driver's license and not somebody else's. It's going to do a number of those sorts of validity checks just to make sure that this is a good credential. And then it's going to parse the credential, it's a JSON document, and grab within it the the DID identifiers that are within it. Specifically, it's going to look for the DID of the DMV, that party that issued me this credential. And once it grabs that from the JSON, it's going to, as per the rules of the DID method, deconstruct that DID. And the first thing it's going to do is from that DID, grab a file ID on Hedera mainnet. And it is in that file that is stored an address book for the members of the business network. So mixing analogies, if it were a university diploma, all the universities would have their IP and a public key in this JSON file stored on the file service of the network, of the mainnet. Notably, not identity data or not identity attributes about me, the user, but just metadata about the address book members, or sorry, the business network members. So that's the first thing the restaurant does. Grabs from within my driver's license the DID of the issuer, parses that for the file ID of the address book, goes to mainnet, retrieves that, it'll be a small cost, some fraction of a penny, and retrieves that address book and likely caches it away for future use. Then it parses that address book, which again is just another JSON document, and grabs one of the business network participants. Could be random, maybe they have a relationship with one of them, and sends a resolution request, again, as normalized by the DID method, which is just a JSON RPC style message against the particular endpoint hosted by that business network member. What they get back is useful metadata, specifically the public key likely of the DMV, and it's going to use that to validate the DMV's signature. It might also retrieve the revocation status of that credential, because if the credentials was issued to me 2 years ago, the driver's license was issued to me 2 years ago, maybe it's expired since, and the restaurant needs to know that. Or if it's a university diploma, the job at which I'm applying needs to know if they took away my diploma for whatever, cheating, which I didn't do.
Thanks for putting that on the record.
Yeah, I thought it important. So
That's
the model.
Question is, how much is the cost for each lookup when querying HCS? Just a little side note here, like, how cost effective is this? And could you maybe talk about the lookup model for those things?
So the lookup model does not touch HCS, right? These are reads. They're just queries against the business network or the mirror network, right? And so if you wanted to retrieve the running hash, the full list of messages for this topic. So whatever charges are associated with those queries is not set by Hedera. Hedera defines the prices for those HCS messages on the left, the creates, the updates, and the deletes. And the base price for an HCS message is 1/100th of a penny. So depending on maybe how big those messages are, maybe it's slightly more or less than that 1/100th of a penny.
Awesome. Thanks for answering that question, and thanks for asking it in the YouTube chat as well, folks. If you have any additional questions about anything Paul talked about, keep asking them in YouTube.
Yeah, I think I sort of generalizing a bit. I think about HCS use cases maybe as falling into two broad buckets. There's one where there's a network of businesses or participants who want to share data amongst each other, don't want to rely on any one of them to be the arbiter of what is good data, and want to be able to have auditable records of the sharing of that data. for potential use down the road and disagreements. And the other broad use case, I think, is where potentially just a single actor doesn't need to sync data because they're just one of them, but they do want to be able to, after the fact, prove that they did something. And the HCS provides the potential for down the road being able to demonstrate that you did indeed do some business activity. And this did model kind of feels like a bit of both of those, because the members of the business network are definitely syncing amongst themselves this registry of these artifacts, the did docs and hashes, et cetera, so that they can be confident at any moment in time, they're all basically looking at the same database. And so can be confident that, for instance, if one of them revoked a credential, if one of them took away my driver's license, then within 3-5 seconds, all of them would know that and could immediately update their database accordingly. And so, minimize the risk of a window of uncertainty or latency in the network.
Yeah, those are great patterns, Paul. And I think a lot of our challenges actually kind of hint at those, but don't quite outwardly say them in full. So maybe we can now transition to talking a little bit about the HCS challenges, unless you have anything else to cover here, Paul.
No, happy to clarify further after the fact.
Fantastic. So let's go back to the backdrop of our challenges. We have some good ones that I think most people are aware of. All right, and I assume you guys can all see this. So we do have a number of challenges throughout the hackathon. These are the Hedera Consensus Service specific ones, and the ones that'll probably give you the best ability to win one of the grand prizes. And I think it's really important to think about how these can affect, different industries. They can be industry agnostic. There's a lot of different potential for putting these into action. And so I'd like to quickly go over each of these at a high level, and then perhaps, Paul, Cooper, and I can chat a little bit about where we see these being interesting, throw around some ideas that we like, and, something that can give you a good spot in the hackathon for the competition. So we definitely see a variety of industries being applicable to these. And it's important, I think, to either go in with the mindset of I'm building for this particular industry, or I'm building this flexible tool that can be used across each. And that can be a really differing view for how you approach the hackathon. And do you build an API that works for each of these, or do you build more of a full stack solution? The first is really fair ordering. So use cases in which the order of the transactions has a high need or desire to be ordered fairly, unable to be manipulated by a single party. You can imagine this is helpful for bids and asks or retail bidding scenarios. But not just that, I think even in Paul's examples, right, where they're talking about, was this revoked or not? The order of those transactions really matters. And in those cases, still for fair ordering, you might not think of it at first, but it plays a huge and critical role. Similarly, for proof of action, this is really the ability to prove or have evidence that an event occurred. So this is a big one, I think, and has so many different applications, but really having an understanding of who is signing what data and when that was sent is the outcome of it. This could be very good for data and regulatory compliance, or proving a supply chain use case, a number of things. And then the final one we have is audit logs. This is certainly taking advantage of the transparency and availability of the ledger to work with authorized parties or publicly information, but really sharing and showcasing that to the interested parties. There's a really exciting number of use cases there as well. So with that, I thought, maybe we could go a little bit of a round robin brainstorm session and just talk about some of the use cases that we find the most interesting. I am happy to kick things off here with a couple. I think one that we talked about internally, at least, is kind of this notion of SLA monitoring. So an audit log for things like the Hedera network, cloud service providers. You could certainly spin up an API pretty quickly that allows you to constantly, be pinging these things and getting responses to have this validated third party of information. How is that? You seeing someone you know, Paul?
Yeah, friend just drove by on a bike.
Oh, fantastic. But and this is something that can be applicable again across a number of use cases, very easy to implement. You're starting to get some data coming in that is a high right use case, taking advantage of HCS and providing more verifiable evidence of the actual SLA that some of these providers are delivering on. I find that a pretty interesting and certainly an easy MVP to build for that. Are there any identity ones that jump out at you, Paul, as an interesting starting point if someone wants to sink their teeth into the DID spec?
Well, I see personal data consent on the list, and to me that's a different aspect of identity than DIDs. Sure. Because in this context, proof of action, the scenario of recording a user's consent to some sharing of their PII is fundamental to all the new privacy regulations that are emerging. GDPR as kind of the archetype. So it's easy enough to say that you recorded a user's consent to some subsequent data sharing, but it might be very valuable to be able to prove that you did indeed record a user's consent for a given operation at a given time, right? And that proof could be endorsed or given confidence in if the capture of that consent was recorded via an HCS message, right? Absolutely. Hopefully, you'd never actually need to use that proof in any sort of adversarial relationship. But just collecting every time a user either provides their consent or changes their consent or revokes their consent, all those consent lifecycle moments, record those via HCS and give that immutable log of consent operations.
Sure.
Both useful to the user themselves, because they'd be able to look at this list and remind themselves, oh, yeah, indeed, I did say that was okay. And have confidence that the list was indeed accurate and not manipulated by the whatever provider happened to be storing the data.
Yeah, absolutely. That makes sense. And I think you could, simply start with a pretty simple API, probably the right abstraction for something like that, do you think?
Yeah, absolutely. It's, it's, as you say, it's a simple API, right? You want to give the user some UI that makes clear what they're consenting to, any limitations, any terms, any conditions on that consent, allow them to say yes or no, probably record both, whichever they chose, and then hash that interface or hash the data elements that made up that interface and record that via HCS and store it away for future use.
Yeah, that makes a ton of sense. Cooper, what great ideas are you holding out on us about?
So kind of inspired by your initial kickoff idea, I was reminded of how Slack went down last week, and people were kind of wondering what was going on, if they got fired from their jobs, or if it was just an instance of cloud outages. And so how this really works is that Slack has admitted in the past when Slack goes down that they communicate via Skype, and they fall back to a service offered by someone else in order to, communicate with their teams. So I really think, providing uptime logging or uptime availability from different parties, where instead of having to check Slack servers or fall back to, another service that's offered by a centralized party that could be a competitor, it could make a lot of sense to log your availability and uptime to a network like Hedera that is not owned or operated by a central entity and has no incentives to lie to you about whether your service is online or deplatform you in any way. So something like that, I think, would make a lot of sense, where you could have a specific message specification and a specific topic dedicated to, availability and uptime of services. And you could even be a third party that's just, pinging those services to see if they're available and logging the results of those pings on Hedera. So that's one use case that's kind of interesting. Some of these things that people are building are going to become so important that you really need to know if it's your fault that you can't access them, or if it's the systems themselves, or these other things. So kind of like an auditable log of uptime for different services could be interesting.
So,
yeah, definitely.
As you described it, it occurred to me that, of course, nothing in that model would prevent a bad messaging app from lying about their uptime and reporting that via HCS. What I think HCS enables is it allows a good actor to prove their goodness, right? It doesn't prevent a bad actor from being bad in this model. It allows a good actor to demonstrate that they followed the rules in a more credible manner than just asserting so themselves.
Yeah, potentially if you're worried about the bad actors of the world, you could have some type of aggregation where, in this specification, it's everyone's attempting to access Slack or different services would all be logging their results of those pings. And, if a majority of those are failing and you have a sufficiently high enough number of those people, you could potentially rule out bad actors. It just depends how you kind of architect it, I guess. And if you are content with a majority-based consensus there.
Yeah, agreed. The more writers to the database, the more reliable.
Yeah, kind of like an Oracle aggregation service where, instead of just trusting one person offering that API or that ping result, you could take 1,000 of them, or, however many users are trying to access a given service at a time, and get a pretty good picture of the world. If that outage is in a specific geographic location, or if it's just affecting, a subset of users, you could definitely take kind of like an aggregated poll and then log all of those results on Hedera to get a better picture of the auditable history of those services.
So then a company like us, or the employees of a company such as Hedera, would be able to query that database before any given call and determine which of the 10 or 20 available chat channels that were available to us would be the most appropriate.
And you wouldn't have to go to a competitor to discuss and see if it's just an issue on your end or an issue with your systems, and those types of things as well. You could build some type of unbiased auditing system.
Or this would be a decentralized, is it down for?
Yeah, exactly. It's like a peer-to-peer version of that. Yeah, certainly interesting. Gehrig, do you have any? We're going round robin, so I think you're up next.
So I think what's interesting is kind of this foundational layer of data shared between parties and making use of that through other applications. One that I think is, a good formula for that, and actually using likely a DID specification, is history of work employment. And so not only are you, attaching the signature of your work and verifying that information, but you're able to use that in, many different areas, whether that's, social networking and LinkedIn-like use cases, or access management and getting into the building, or having access to IT tools. I think it's an interesting thing that could certainly scale to a number of helpful areas. Do you guys have any thoughts on that one, or
Yeah.
proving credentials at large?
I think the DID model, or more specifically, the verifiable credential model, is particularly relevant in a situation such as that, where the authority asserting that you were an employee for 1 or 2 years
Mm-hmm.
shouldn't have the right to merely on a whim refuse to assert that. Once you leave a company, potentially on bad terms, that employer, that ex-employer, may have an opinion as to whether or not they issue a recommendation, but they shouldn't be able to merely on a whim refuse to assert that you were an employee. That's a fact.
Mm.
And the verifiable credentials model better supports that sort of autonomy or sovereignty on the part of the holder of credential. Because in the model, on the day I leave the company, I get a verifiable credential that says I was an employee from day 1 to day 2. And then I should be able to present that on my own terms to potential future employers or banks, whatever, if I'm going through a KYC process. And I shouldn't be beholden to my past employer.
Yeah, absolutely. And I think it's interesting that when you think about the kind of portability and composability of that data, you could certainly sell that information for more analytics, or, there's a number of ancillary use cases and applications that would want to take advantage of that, which is pretty neat.
So
when I think about, oh, go ahead, Paul.
No, you, Cooper.
I was going to say, when I think about what it takes to build out, kind of like a very broad ecosystem for decentralized identity, there's going to probably be dozens, if not hundreds of issuers and, verification points kind of across the way, depending on use case and need and all these different things. So if you think about how you take something like just an over 21 identity verification, something that's going to become pretty standard on the internet when you can buy alcohol, you can do all these other things that you can't if you're under a specific age.
Sure.
The abstraction point that you're looking at as someone building a business there is very different in my mind than building out the entire ecosystem by yourself. For example, creating some type of, for the hackathon, and in this context specifically, some type of issuance service that can be dropped into different businesses, maybe your local gas station or wherever it is, as a mechanism for doing that identity verification and subsequently issuing those credentials onto any public ledger that exists, is kind of a different abstraction point within the DI model that could be a very, very viable business, where if it's super easy to walk into a gas station or store, show them my ID, and that gets subsequently logged on Hedera for whatever, that person wants to do. And we're just kind of the issuance of credentials that, you can build up an ecosystem of companies, websites that take in those credentials and verify them and use them to attest to the fact that I'm over 21 and can buy alcohol on the internet, or, something of that matter. So I think that there's, a bunch of different kind of abstraction points or business models within that kind of whole DI landscape that are either potentially good hackathon ideas, but also really, really good businesses moving into the future.
Yeah, fundamental to the DID model is the proposition that, there are multiple ledgers on which a DID could be registered, or maybe not registered at all, and that a verifier, a relying party, that gas station, has to be insulated from the specifics of each of those DID methods. So there definitely is an opportunity for that abstraction layer in the architecture.
Yeah,
So
you could imagine. Sorry, I was going to say, you could imagine walking into a gas station and then like passing in your ID card, maybe giving it to the person at the counter who scans it. You could pass them their public key, as well as tell them, where that account is associated with, on which network, whether it's Hedera or some of the other ones, because we all build to the same W3C standards, at least hopefully. And then you could basically have this type of business model where people could even pay a reasonable amount of money, maybe $10 or something, for their credentials to be verified and logged according to their account. So it's definitely a unique model there, and it's going to take out a lot of different businesses and tooling to, bootstrap that infrastructure.
Indeed. I'll throw out another DID identity use case. It's topical. The potential of a so-called COVID credential has been floated in the industry. The basic premise, I think, is that if someone had COVID and got through and presumably had the antibodies, then if they were able to prove that medical history and the presumed resistance to future infection or infecting others, then potentially that might gain them enhanced permissions in society. Like maybe they can get on a plane where others can't.
True.
So I suggest that with caution, right? Because there are clear privacy concerns about society jumping too quickly into that model. But I think, I guess I would suggest as a potential hackathon project, it wouldn't be inappropriate to explore that and also explore the privacy implications associated with it. And that could be an interesting social good project. I'll note that the ability to revoke such a credential could be life and death, right? If this were implemented for real. Let's say the test that deemed me safe was subsequently proven to be a bad test, then the credential that I have on my phone that asserts that I'm safe from COVID and safe to others, definitely needs to be withdrawn.
Yeah, very interesting stuff. And then we have a couple good questions on the DID from Alex. Thanks for the questions, Alex. Could a user be both an issuer and a holder?
Absolutely. In that case, the credential is so-called self-asserted. We can all say things about each other. Mm-hmm. Or if I'm issuing a credential to somebody, maybe it's just a reputational credential, right? It's just I'm asserting my opinion as to their qualifications or coworker skills, kind of in the LinkedIn model, right? And in any given context, a given actor could be an issuer. The DMV would issue driver's license, but they'd have their own credential that asserted that they were the DMV, potentially issued by the government.
Turtles all the way down.
Hopefully we stop somewhere. Turtles all the way down suggests high TPS. So let's.
This is true. And then Cooper, it sounds like we have another question, but we have a presentation already lined up for that one. Is that right?
Yeah, so someone asked, could we discuss maybe the broader kind of use cases related to tokenization as opposed to tokenization of assets? So community reputation points, or, different types of like governance tokens, or all these types of cool things that you're seeing on other distributed ledgers. We actually have a presentation that we're planning as our next Hedera virtual meetup. We will drop the link to it in the YouTube chat, but we'll be joined, I'll be joined by Donald Thiebaud, Director of Product Management, as well as Tim McHale, one of our lead developer advocates, next week for a presentation that discusses just about everything with HCS tokenization, from security tokens to how you actually build those, what those standards and specifications might look like, as well as some of the things that you might want to build with them. If you can't wait until next week and really want to get started, I would check out the 4-part blog series that we actually just released, which showcases how you can kind of build those governance tokens, reputation tokens, all types of tokens on the Hedera Consensus Service and what the different kind of architectural models look like. We also have an example GitHub repository that you'll find somewhere in there, which shows how you can map like an ERC standard to the Hedera Consensus Service. So hopefully you can hang on until next week, but if you can't, feel free to dive ahead into that blog and the code that we have available.
So in that blog series, Greg and Tim teased out 5, I think they called them building blocks of a tokenized asset on a business network, right? And it occurred to me as I read that blog that what they were describing was the HCS did model, in that we are going to use HCS messages to allow a community of participants who don't necessarily all trust each other to nevertheless agree on some business state. Now in tokenization, it's who owns how many tokens of token 1 versus token 2 and so forth. In DIDs, verifiable credentials, it's not about ownership necessarily, it's just more about that registry of metadata. But the building blocks that Greg and Tim described are the same, I think.
Yeah, absolutely. Just to briefly touch on different use cases for tokens. There's so many. Like I mentioned, just reputation points, community rewards, governance voting, stake models, proof of kind of skin in the game, or the fact that you own specific tokens as kind of like an entry point. There's a lot of potential use cases there. And that actually will be its whole own webinar. So very much looking forward to that one. And I hope you can ask, subsequent questions there.
Gaming.
Yeah, digital gold is a great one. Lots of fun stuff.
I see Alex posed a question about just clarifying the DID registration process. The premise, Alex, is that yes, the user or somebody creates a public private key pair, encodes the public key in this DID document, the JSON document, signs it with the private key, and then that signed DID document is registered via the, in the Hedera context, via an HCS message with a create message and the base 64 encoded DID document. And that's communicated through HCS, through the mirror, back out to the business network, where that DID document is persisted, such that when the DID is subsequently presented to a verifier, the DID document can be looked up. And the public key within retrieved, presumably for help in validating a signature.
I do have an additional use case I was going to throw out there, which is just auctions. So, an eBay-like integration where, or concert tickets is a great example. So every year Coachella's website goes down or has issues with people, being in a queue for a few hours due to inability to access their servers or their centralized infrastructure. And it's a very unfair model where you have like computer nerds like me that are going in and trying to look at the code and see different ways that they can submit their asks for tickets before others. And so you have this very kind of centralized gatekeeping distribution model, or it's kind of like a ticket auction where it's, first come, first serve. But what are the rules for that first come, first serve for tickets? And so if you build something on a decentralized network like Hedera, where you actually have a specific topic dedicated to the issuance of those tickets, Hedera will, by default, give you a sequence number for every bid or ask within that kind of auction. And so instead of trusting, Coachella, whoever is maintaining that distribution infrastructure, you could actually have everyone just submit messages to Hedera, whether through one website, through their mobile wallet, through any type of third-party applications, and you would be able to prove who should be awarded those tickets based on the history of events logged in Hedera. So it's a much more fair and equitable model. It has all the security and uptime properties of the Hedera network rather than, what might be a badly maintained server infrastructure. So I think, eventually users will become so upset with how bad those ticket distributions are, especially when you see things like Nike shoes, like specific branded shoes getting sold out within seconds.
Mhm.
Eventually someone will provide a better user experience for those things, like building on top of Hedera, and it will quickly become an industry standard where just going down when you have a major release is just not an option.
Yeah, I like that one, Cooper. And I like how it's so applicable across a number of use cases too, not just the ticketing example. But you can imagine with waitlist for, even COVID testing or whatever it might be, that's going to be a growing need. Well, very good. We only have a few more minutes here. Does anyone have anything they want to add or be sure they get out? I think we covered a number of good patterns and kind of examples that people can start to wrap their brains around.
Yeah, I love that fairness. Anytime multiple people are competing for the same scarce resource, you need fairness.
Yeah, I think, one of my biggest suggestions for, people in the hackathon and thinking about HCS use cases is, like Gehrig and Paul said, is think about right abstraction points. A lot of these solutions are very broad in scope and require, large efforts, kind of like the DID example where in the future, if decentralized identity is successful, you can imagine every gas station in the country having a way to verify those credentials or, a similar model. So thinking about what you can solve or what you would like to demonstrate within the hackathon, instead of trying to solve, the whole broad scoping problem, think about, the pieces or the abstraction points that make sense, either as a business, as a proof of concept, as, just an example, or even just something that would be fun to work on. Like if there's one part of it that's more exciting than the others, totally feel free to de-scope what you were thinking and solve one of those problems, but do it so well that anyone else would be able to leverage your solution in what they're building.
Yeah, great. Well said, Cooper. I really like that. And that's a good takeaway, I think, to drive us home here. Well, thanks so much for everyone joining today. I think we have, each of us actually have mentorship time available on the application. If anybody wants to schedule time with us or, feel free to hop in Discord and get information there. But hopefully we gave you enough concepts to work with and start to build towards. I'm excited to see what everyone builds. Good luck hacking. All right, bye guys.
We'll see you on the town hall in 30 minutes.